Hey everyone, welcome to Devlog 2. Before we get started, we just want to thank everyone for the overwhelming support we've gotten on our game so far. You guys have made this indie game dev thing really fun for us, and we truly appreciate that. In this video, we'll be showing off our AI features, animation overhauls, and several miscellaneous improvements we've made since our first devlog. Also, in the next couple months, you can expect our official Steam page to launch, so be on the lookout for that. As we discussed in our previous devlog, we want to keep the gameplay loop simple. When designing the behavior and functionality of the basic infected, we often had to scale back the complexity. The replayability of Project SafeRoom doesn't come from the AI itself, but it comes from the AI director. The director orchestrates the spawning, despawning, and special events that are happening throughout each playthrough. While we won't discuss the AI director in detail in this devlog, it's important to mention it for clarity. The basic infected can enter 4 main states: idle, aggravated, stumble, and chasing and attacking. Many of these states are unidirectional and cannot be reverted due to the design of our gameplay loop. This means once the infected enters the aggravated state, they will enter attacking and chasing soon after. Once in attacking and chasing, they cannot return to idle or aggravated. The only state an infected can re-enter is the stumble state. This is because it can be activated by the player at any moment. Once the stumble is completed, the infected will immediately return to the chasing and attacking state. The infected have 2 main senses: hearing and sight perception. Sight perception will trigger the aggravated state if the player comes too close, and the hearing perception will trigger if the player makes a noise too close. Infected that are not engaged by the player need to despawn appropriately to be respawned in a more optimal location. We want to create the impression that hundreds of infected are spawned in a level at once, but obviously that presents significant performance challenges. This is where the AI director's dynamic spawning and despawning come into play. We've been experimenting with a feature in Unreal Engine 5 called the Environment Query System, or EQS. It allows AI to perform a series of tests or queries to determine the best possible action based on specific criteria. For example, say there's a scenario where the AI needs to chase the player, but there are several obstacles blocking the direct path. EQS will run a series of tests to find the most optimal path for infected to take to reach the player as quickly as possible. You can see orange, yellow, and green spheres marking the best path because they have the highest scores. Blue spheres are outside the range of consideration, so they are automatically a score of 0. With this feature, the AI can dynamically adapt to the environment and choose the best method for navigation. We're still not even sure if this is a feature we'll end up using, but we still think it's a really cool option. Our game will feature multiple infected enemy types, but we're only ready to show off our basic infected in this video. Our different infected enemy types are really going to improve the co-op experience, but please remember that we are still in early stages of development, so everything you see is subject to change.
Animations are one of the most important parts of any game. There is constantly an animation playing, even if it's just the idle sway while you're AFK. Clunky animations can completely break the immersion of your game, which is why we spend so much time making sure our animations are the best they can be. For first-person animations, we create everything completely by hand. Since you're seeing these animations at all times, they have the biggest risk of being clunky and breaking your immersion. This means they must be extremely smooth and responsive. We have had a lot of trouble getting these animations to a quality that we're happy with. We've encountered challenges in both Blender and Unreal, including skeletons, controller rigs, importing, retargeting, and everything in between. It's been a constant struggle, but we finally found an effective method to create animations in Blender and transfer them flawlessly to our character creator skeleton in Unreal. When it comes to third-person animations, we do things a little differently. As we mentioned in our last devlog, we're using a mocap software called Move AI to help create all of these animations. This includes the animations you'll see on your teammates and the infected. We knew from the start that a wide variety of infected animations would be essential to keep the game fresh and engaging. With just a 2-person team, we're not able to achieve the quality and quantity of animations that we want if we animate everything by hand, which is why we chose mocap. It has its problems and requires some fixing, but this approach is still far more efficient. Mocap has honestly been a lifesaver. One of the hardest parts of animating is trying to recreate lifelike movement. Mocap doesn't have this issue because it captures the micro movements of every bone, so the rendered animation looks almost exactly like what you acted out. Move AI generates a key on every frame, so even though it's not perfect, it makes it easy to clean up without losing that lifelike movement. Recording mocap has been super fun. It gives us a chance to step away from our computers and really get creative with our animations. Plus, seeing your real-life movements come to life in-game is really cool. We recorded some behind-the-scenes footage of our last mocap session, so if you want to see that, let us know in the comments. As we mentioned earlier, animations are extremely important to any game. Our work is always ongoing, and we continuously return to enhance older animations as our skills improve, so I'm sure there will be more updates coming in future devlogs.
We saw a lot of feedback on Devlog 1 regarding our weapons, so we've made several improvements and additions since. Some of these enhancements are purely cosmetic, while others impact functionality directly. The largest criticism was our weapon firing animations because they lacked realism and feel. Now we're using an advanced plugin to simulate our first-person procedural recoil. It uses vector curves to create the base recoil animation by using X, Y, and Z values. Now that the base recoil animation is set with the vector curve, each weapon has its own set of data assets that help in adding variation to each weapon shot. Each data asset contains tons of different value ranges for every possible direction, movement, and speed. Metasounds is a new audio system in Unreal Engine 5 that gives developers better control over their sound sources. We're using Metasounds to improve our weapon fire consistency and add different audio effects. It wasn't really an option for us to record actual gun sounds, so we purchased high-quality sounds instead. We use these purchased sounds as the main sound layer and change the pitch and volume of each fire event. This gives off the illusion of dozens of different firing sound effects. We believe that making a game hard just to keep you playing longer is poor game design. You need to find a good balance between making the game challenging and ensuring the challenge makes sense while playing. We're adding firing and accuracy when moving and jumping. This way, you're more likely to stick with your teammates and methodically traverse the level. Don't get me wrong, running and gunning is so much fun, but that doesn't really fit with what we're trying to achieve here. Our game relies on communication and teamwork to get between safe rooms, so you need to make it difficult for a player to quickly run through the level without any complications. It won't make firing while moving impossible, but it will make it more difficult to maintain accuracy. Melee weapons will be one of the most common weapon types in Project Safe Room. To introduce some variety, we implemented a sequence of melee attack animations. When you spam the melee button, the game will cycle through a specific sequence of animations until you stop. If you only attack once, it will begin a timer that will shortly be reset after that attack. If you engage another attack before that timer expires, it will play the next animation, ensuring nothing repeats. This will prevent the same exact animation from playing over and over again if the player continuously spams the key. Muzzle flashes and case ejection are entirely cosmetic but help tremendously with immersion and feel. It's the type of thing you might not consciously notice is there, but you'd definitely notice if it wasn't there. The case ejection is just a basic Niagara effect that spawns from a designated socket on the weapon mesh. The muzzle flash works similarly but also emits a light in dark environments.
When we first started developing our game, we fell into a common trap that many indie devs do. We were super excited to bring our ideas to life, so we dove headfirst into building without even considering optimization. Now that we're almost ready for our first private demo, we need to take some time to get the game running smoothly. We started by revisiting some major problem areas that were hindering performance and brought them up to a more playable state. The most problematic area was the park, where we would only average about 30 FPS. After cutting back on some of the foliage and actually applying proper level of details, or LODs, to the trees, we were able to more than double it, and now we are getting about 70 FPS. Now, this still isn't fully up to our standard by any means, but it's a start. We didn't only focus on the problem areas. We also took some steps to optimize the map as a whole. Originally, we were using exponential height fog to limit view distance. We knew this wasn't the right way to do it, but like I said, we were super excited to get our ideas out there and we just wanted to create the level. We've now switched to a less resource-intensive fog material applied within the post-processing volume. Additionally, we added a cull distance volume that despawns assets when they're beyond visible range, so there's no unnecessary load. Everyone should be able to play and enjoy our game without having to worry about computer limitations getting in the way. Currently, we're focusing on lighting optimization, reducing hard references, network stability, and many other improvements so the game runs smoothly for all players. We also want to show off a few other miscellaneous features that we've been working on, but don't fit into a category in this video. To make our game more unique and not just another asset flip, we've started implementing our own models and textures. These are just some of the signs that we've taken from real life and put into our game. When we're out and see something interesting, we take a picture of it, throw it into Photoshop to clean it up a bit, and put the texture into Unreal. Early on, we knew that having some sort of shove functionality would be a must for the player. Without it, it becomes nearly impossible to free yourself from total encirclement when there's a large number of infected. We're spawning a box trace to detect any infected that are in front of the player. If the trace overlaps with an infected, it immediately goes into the stumble state and gives you an opportunity to free yourself. Currently, there's a cooldown on how quickly you can spam the shove, and we'll constantly be tweaking this during testing. At first, we were using Unreal's metahumans for our characters. They were resource intensive, complex, and didn't really give us the customization we were looking for. We switched over to Character Creator 4, and now we're able to create the character models like we envisioned. These are still earlier renditions, so we will have more details about them and the infected models in the future.
Thanks for sticking around and watching our second devlog. We've been getting a huge amount of feedback since we first announced our game, so please keep up the constructive comments and ideas. It helps our project so much. Make sure you check out our Twitter, where we consistently post behind the scenes footage. This includes our weekly dev update, where we share our progress for that given week. For short form content, we post on both TikTok and YouTube Shorts, so check those out as well. As I mentioned in the beginning of the video, our Steam page will be launching soon along with our official game title. No, Project Saferoom is not our actual game name. Also, we are in the final stages of preparing for our first private demo, so if everything goes smoothly with that test, you can expect the public demo shortly after. Make sure you like, comment, and subscribe to our channel, and thanks again for sticking around.